Thank you very much, Amir. Thank you, Hugh, the whole SWAN team, for giving us the opportunity to talk to you all this afternoon. It's felt to me like there's been a great energy in the room all day, and hopefully we can carry on with that and continue to build on it. We would like to, as I said, make this an interactive session. So we'd like to use the Slido platform. You can use this QR code. We're going to be asking you to give us some input as we go. So please grab your phones and let me move out the way so there's no feedback. And head over to slido.com, either using the QR code or you can go in and use SWAN CT if you just want to get to the website itself.
Yeah, so 2 ways to get on. You either scan and it'll take you straight through to the website with the code embedded, or you can type in sli.do or equivalently slido.com, and then it'll take you to a prompt to enter the code, and then you'll enter SWAN CT. Okay.
Any problems? Are we moving in the right direction in terms of Slido? Great.
Yeah, I think let's assume we're good.
Okay. So, I'm going to pick up on 3 key themes that have become evident to me through today's conversations: data, value, and trust. And through this session, hopefully, we will provide an answer to the question, how do we leverage data to generate value, and how do we do so without eroding trust? So if we look at the greater city of Cape Town area, I picked up an estimate online that there are somewhere in the region of 1.2 million households with piped water access. If, and it's a big if, there was a smart meter on every one of those connection points and it was reading every hour, you would end up with 10.5 billion data points per year. So the question is, how do you leverage that data? That's a huge amount of data. Processing that as a human is very, very challenging. An answer to that question, and it's the answer we would put forward, is artificial intelligence, AI. One of the big, big buzzwords of the moment. What we'd like you to do, please, as the first Slido exercise, is tell us what comes to mind when you hear artificial intelligence or AI. Just throw keywords or key phrases into the Slido board, and those should pop up. There we go. We've got 5 people typing. All right, robots taking over the world. Taking over the world. Resolving complexity on a slightly more positive note. Automation, machine learning. Efficient regurgitation, that's an interesting one. Quantum scale, robot that can do your work, huge opportunity. All right, so perhaps not unexpectedly, there is a variety of sentiment across the terms that are going up there. Some positive, some negative, maybe somewhere in between. What we're going to try and do now is help everyone align on a definition of AI and the different parts of AI, and we're going to talk about how this might be leveraged in the AMI space. So I'm going to jump on to the next slide. So we're going to talk about artificial intelligence, data science, and machine learning, all just modeling. In terms of artificial intelligence or AI, the technical definition is this is the ability of machines to make decisions and take actions typically associated with biological intelligence. In other words, us. Within that, we have machine learning, which can be broken down into 3 different categories, broadly speaking: supervised, unsupervised, and reinforcement. These have different approaches to generating the models and different contexts in which it is appropriate to use them. And then deep learning as a subset of machine learning, where we're talking about neural networks of a particular type. And there are a lot of technical terms in there, but one of the things that we would like to focus on is the conceptual understanding that we feel you will need to understand these things and make sure that they're used appropriately in your business contexts. So in terms of modeling, it's a 3-step process. Training, which is defining or learning relationships between input data and output data. Test processes involve validating those relationships, and then deploying and running the models is making a new prediction. And so the fundamental principle at play here is you have an input or inputs, you have a model, and then you have outputs. And James is going to go into more detail on that in a little bit, but I'd like you to just hold that in mind. Input, model, output. And then alongside that, and partially overlapping, we have data science, and that's perhaps more simply the study of data to extract meaningful insights. So this would be descriptive analytics or visualization that sits alongside some of those more complex approaches. And all of this, to use another buzzword, sits on a foundation of big data in some cases not such big data, but there still might be a lot of value to be had. James, over to you.
Awesome. Okay, so Matt has put forward the idea of input, model, output. And now we really just need to understand what exactly are each of these. This is the process of taking information. This is what your input is. And that information can be in any form. It is every click on a phone. It is every message you type. It is every sensor reading that comes in. It can be formatted as a spreadsheet. And in this situation, we have something that is relatively structured. We have a whole bunch of rows or line items. We have a bunch of features or columns. And then the question from here is, what happens if you have a bit more of that and a bit more of that? Or what do you do with all of these like sets of information as they stream in when you have not only a couple of sheets, but you have tens of millions of readings or billions, as Matt showed in the first example? Or what if it's not in this structure at all and you have something in the form of a photograph? What do you do with all of this? Well, you're going to need to model it somehow. And the model is going to vary quite drastically depending on what the data input is. So you need to start with the idea of this structure, which is why we introduced it like this, with the input, model, and output. You need to know what you're trying to do with your information, and you need to know what information exists, so you can then choose how you are going to quantify those patterns. And this quantification can be as simple as a straight line. If we have a scatter of points, I'm sure we have all dealt with basic level mathematics, where we've drawn the best fitting line through a series of points. We can do that quite easily, and we can quantify that relationship. What we get out of this quantification is the relationship or the impact on y from a marginal increase in x. What happens if that's slightly more complicated? If the data changes, well, we still are actually able to interpret some level of patterns out of this. How we might start splitting it, though, is going to be quite different. Let's find a line that best divides these two sets of data. And then we can find another line that best divides one of those subsets as well. And in this way, we can actually go ahead and model the patterns or the relationships that exist over here. Which leads us a bit into the output, because we need to consider what is coming out. What if there is a numerical quantification for each of these shapes that we see over here? We need to think of what is coming out, and we need to do something with that. So if we think back to that unstructured example, we've got a photo, or in this case, it would be a whole bunch, probably a few thousand different images that we're dealing with. We want to take those photos. We want to be able to identify features from within that. And those features, when it was a text file, was relatively easy. It was just each of the data entries per column. When it's a photo, it might be a reality at a meta level of has eyes, has ears, has paws, these kind of things. Technically, what we would be doing is we would look at every single individual pixel over there. Each of those would be a feature. We would then use some level of mathematics to draw out those meta-level features from there, and we would get out an excellent prediction, which is obviously a rabbit. So your output is a prediction or a set of predictions. It varies a lot depending on what the problem was that you were trying to solve. You can have a house price model, which is naturally going to predict house price coming out. Weather models are going to predict the temperature that's coming in the next 24 or 48 or whatever hours. Insurance models, now you're predicting a probability. What is the likeliness of such an extreme event, whatever that extreme event is, of happening? And ChatGPT amusingly predicts likeliness of words. So all this does is it looks at what has been put through as the input at this point, and it goes based on all the mathematics, all of these algorithms that is essentially a black box. What is the most likely word that would come based on the information that it has learnt? There was a really good point early on in the word cloud that was, something around intelligently rehashing relationships or information. And that's essentially what's happening. You're looking at everything that the model was trained on and re-putting that information out there, maybe in a slightly different structure. Which takes us on to the next point, application and trust.
Will you skip to the next slide so I can start talking? Okay, thanks, no problem. All right, so input, model, output. That's the fundamental concept we want you to hang on to. And with that in mind, looking at applications, a statement that can be made is machine learning supplements and advances human capabilities in volume of information processing, speed of operations, detecting complex patterns, objectivity, and repetition without degradation. So there are your benefits of moving from having a person trying to process data, especially on an enormous scale, to having a model doing some of that work, or most of that work. And the specific applications that this might allow or feed into would be prediction. The graph there is an example of forecasting forward in time. Then anomaly detection, looking for outliers, looking for departures from established patterns within the data. Language processing, ChatGPT came up in the word cloud. It's an example of language processing and then generating an output based on what is fed in. And then finally, clustering, where it's not a linear pattern, for example, but a decision boundary that's being defined based on multiple variables within the data. In line with this, and in line with the theme of trust, we wanted to touch on trust and transparency. So again, based on what came up in the word cloud at the beginning, there's a lot of concern around what AI is going to do, how it's going to change the world. And that's justifiable. It stems from reality. And increasingly, there is research being done around AI ethics. And this has identified 3 pillars of transparency. One of these is interpretability. How does the model work? So what are the actual operations taking place under the hood? The next is explainability. What drives the model outputs? So if you have a customer who says, why did the model say this about me? You can go and say, well, these are the important variables that are feeding into that model. This is the relationship between the prediction and those variables. And then finally, accountability. Again, it's increasingly the case that there is regulation around these things, regulatory compliance is required, and businesses need to be able to, and organizations in general, need to be able to explain, validate, and document whatever models or systems they're using in this space. James, over to you again.
Awesome. Oh, I don't actually need the clicker, but I've got it anyway. So, in this section, we're going to do a bit of a group discussion. So this is going to give everyone a chance to engage. We can stay in the existing groups, I think. It's probably easiest for efficiency. And what we're going to look at is discussing potential modeling use cases within the context that you are familiar with. So we have a whole bunch of water domain experts. We have all of the insight and versatility from various different individuals. And you may have encountered AI in some levels, or maybe you haven't, and maybe you've tried to avoid it in varying degrees. The idea over here is, and we say, let's look at the detailed steps on page 3. Matt, I don't know if it's possible to do that handout at this stage?
Yeah.
So in the handout that you're going to receive, there are a set of 6 steps of what you are going to do as you are trying to solve a problem. And it really starts around the process of understanding what the problem is. Once you understand what the problem is, you can go through into the tools, the ideation of the solution, the stakeholders involved, and work through enacting this process of putting the right tools into place to solve and to trial run a small version of that solution before enhancing and moving on. So this is going to be a Slido poll, but before we go into that poll, I just want to be sure that everyone has the handout and that we have a chance to start engaging in on what a potential set of modeling use cases for AI could be within the water domain, within smart metering, within trying to find a level of value that has not quite been tapped into yet at this stage. So just bear in mind that there are a lot of potential new opportunities that could exist, and this is all about trying to discuss those and work through a structured approach in getting towards a solution.
You can certainly start your discussions in the absence of the handouts. They're on the way. But think about those business use cases. What would a modeling output be? And then what would a desirable input be for that model?
And just to introduce the sort of output that we're hoping for at the end. So we're going to give you about 10 minutes to go through the discussion. And what we would love to get out of this at the end is entries onto Slido of the topic of interest for you. What seems like a great opportunity that you believe is feasible with a level of the AI, machine learning, deep learning tools that have been maybe touched on, or maybe there are additional questions that we could engage around those as well. So for now,
Did you
let's
guys
leave
not
that
get?
for a 10-minute discussion. And Matt and I will also be coming around the room if there are any elements that we can help provide any clarity on. So we're going to leave Slido open so that you can start inputting some of the ideas, so start brainstorming, and feel free to put the ideas in at any level of that brainstorming. Whether you are working through step 1, step 3, or step 6 of that solution, feel free to keep the ideas coming in. And we've got some really excellent ideas that have been coming through. So the idea of this, and we're just going to touch on a few of these, and then we're also going to open up some of the specifics in the Q&A afterwards. So we don't want to spend too much time going through this at the moment, but just to touch on a few of the ideas that have come through. Just the ability to start quantifying non-revenue water, dealing with this vast amount of information that is coming in, dealing with the water balance. And all of these things are able to be done if you understand what is happening at each point within your network. And this all comes down to being able to, water theft coming into that as well. And all of this really comes down into utilizing the data in a functional way. So it starts with the data. You need to take this data into a central store. You need to make sure that you understand what it's able to be used for, what are the potential outputs that you're hoping for, and then taking that a few steps further in terms of doing a level of modeling onto it, getting a prediction output, and placing an action on that output. But yeah, any other things that would...
Was that ChatGPT generated?
Yeah. Any other elements that you would like to touch through in a lot more detail, we can take in the Q&A on this. Something that we would like to open for in your discussion groups now for the next, say, 3 minutes is going through the idea of where is there a huge benefit to AI, but you don't believe that it would be feasible. It would be a huge advantage to be able to have this solution, but there just is a reason that you feel it's not feasible to put in place. So just starting to look at perhaps a level of the disadvantages in the ethical considerations, perhaps looking at the disadvantages in huge amounts of data, perhaps AI is just not developed in the way that it has that level of computational capacity at this point, and the accuracy that would be required is just unattainable. So this is going to be a short session, just a few ideas, keep them rolling. Awesome. So if I can draw our attention back up here, just based on time and engagement, what we would like to start now is going through a couple of the ideas that have been put forward and elaborate a bit more on them. So this is sort of moving, hopefully quite smoothly, through the group level engagement into a larger level engagement. And we want to invite you to voice any of the potential concerns, voice any of the potential use cases that we had on the previous slide, so that we can start unpacking those in a bit more detail. So coming up quite prominently to start off is just this idea of being able to track individuals. So utilizing a lot of very protected information, which actually comes through in many different areas, including within the water network, including as soon as you go down to the specificity of smart metering, which is now associated to specific households, you potentially do have issues with regards to protected, sensitive, personal information. Likewise, in terms of any of the accounts, it was mentioned in an earlier comment considering payment profiles or being able to track and classify individuals. Got some redlining tendencies coming in there, and you can see quite easily how AI could start pulling in very, very problematic solutions. Solutions in inverted commas, I should say. So what any model is doing is fundamentally taking patterns that it has identified and putting those patterns on top of a new environment. And so if you are seeing a lot of patterns that resemble some kind of level of discrimination, for example, the model's not going to really know right from wrong, and you're going to have that ethical concern when the model also makes those same levels of discrimination that it's been exposed to. Let me not read out some of these for fear of my wife seeing this. We have some other concerns coming through in terms.
I saw one that popped up that I am intrigued by, given that it's on this Slido board rather than the previous one, which is customer query resolution. Would whoever put that up be willing to explain a little bit? Because in my mind, I go, well, from an AI perspective, maybe not the actual action, so maybe that's what you're referring to, but understanding the query and responding to the query could be a fairly easy thing to sort out. Would the person who popped that up be willing to comment on it? There's no right or wrong answer at all. I'm just intrigued.
I think in the municipality, there's quite a lot of teams doing quite a lot of query resolutions, and I see the benefit in modeling AI and leveraging AI, looking at various systems and data points, doing predictive forecasting, and even the query resolution. We were discussing some other things in terms of predictive, looking at other data points, but surely looking at the model to be able to alleviate repetitive work and validation and decision making, and just I don't know how feasible is it, but what is, but yeah, looking at that.
Sure, thank you. That is, yeah, really nicely put and a perfect use case as I see it. And there are a couple of different ways to tackle it. So one is to streamline the process for simple queries, which can be done from an AI perspective relatively simply. You can set up a rules-based model that says these keywords are in the query, it should elicit this sort of response, or there are a bunch of conditional statements that give responses that make sense to start with, and then that can mean that query goes to the right team or the right person, so you can funnel things that way. You can also bring in a natural language processing engine that will do more complicated parts of that and actually potentially sound like a human, simulate a human response as opposed to something that is sort of checkboxy along the way. So there are different ways to approach it, and I think whichever one you use should deliver some value. The extent of the value is depends on the data that's feeding into it and so on and so forth. Any other use cases that have gone up either on this board or the previous one that anyone would like to talk through, dealing with exceptions rather than the rule? So these are all the ones that we think might be beneficial but potentially infeasible. Anything on the previous board that you put up that you thought this is a really good use case for AI and I hadn't thought of it before, or you don't think other people have thought of it? Crickets. Okay. That's all right. No worries. We might end up finishing a few minutes early, Hugh. But what we will do is move on to a use case that our company has been involved in, not so much in the smart metering context, but broadly speaking in the water and wastewater domain. And James, I'll hand over to you for that.
Fantastic, thank you. Yeah, there are a couple of solutions over here that are definitely solved. Reminds you when it's time to feed your cat, and there was another one on spell checking. There was another one on setting various alarms and alerts for various reasons. And that idea of alarms and alerts kind of brings us on quite nicely into the idea of a digital twin. So what a digital twin is, and you can look at the image on the right. What a digital twin is a representation virtually of a physical infrastructure. So what you want to do is you want to be able to utilize all of these sensors, all of the meters, all of the data, the information that could come from anywhere. This might come from customer reports of incidents. It might come from the IoT devices. It might come from, obviously, the smart meters themselves. It might come from characteristic data from various pipes throughout the network. Just trying to identify what could be happening from various different data sources. And it sounds like a huge amount of opportunity, a huge amount of risk, a huge amount of complexity as well. So the first step of all of this, after you've identified the problem and the solutions that you're gunning for, is to take the data that is available and to start consolidating that into a central repository and then building on from there. We had a few mentions of the ability to start being proactive and to visualize what's happening. So what we're actually going to introduce is, and it's not mentioned over here, but there are almost 3 layers to taking data and making it usable. The first is representing what exists. It's enabling you to have situational awareness. You want to know what is happening based on all of the different data sources that are coming in. The second level is a level of proactive control. So you're seeing what could be happening based on patterns that have started, and you're wondering, based on the weather forecast over the next 24 hours, what could be coming? Could there be an increased amount of flow through the system, for example? And then the final level, after being a bit more proactive on a day-to-day basis, is trying to identify strategically. Another option that came up on Slido was identifying when assets might be failing, which is quite amusing. That's literally the project that Matt is working on for one of the big clients and in the UK. Literally identifying the health of tens of thousands of different assets. No, it's millions.
It's around 1.1 million at the moment.
1.1 million different assets needing to be monitored simultaneously in order to identify what could be failing and when. So, this is the idea of a digital twin. The digital twin is something that is designed virtually in enabling this level of situational awareness, proactive control, and going all the way into a level of strategic intervention to replace assets potentially before they fail, or to enhance capabilities within the network before they actually become a reality where the network is overwhelmed. So in this case study that we are working through, we had a company in the UK water industry, which has been mentioned at some point before, that provides connection services and data and water. They have the data for, they provide the water to 10 million consumers and hundreds of millions of IoT readings per day. However, when we came into this environment, they had no single source of truth of all of their information. Everything was contained in various different data lakes. Different people inputted their information in different ways, different operators, I mean, in this situation. So operators would take various readings in and around treatment works. Different maintenance individuals or loggers would go through and find out where there were potential incidents happening. Customer reports would go to a separate location as well. And there was no one source of truth. Being able to visualize this network was entirely infeasible just based on the vastness and the variety of big data. If you're curious to know more about big data, you'll want to Google the 5 V's or the 7 V's of big data, which describes the level of complexity that starts coming in. It's basically having a huge amount of data from varying different sources as well. And what we then did as SandTech, although then we were Explore AI, we built the hydraulic network risk tool, which is essentially a digital twin hosted in a cloud-based web application and it has a whole bunch of machine learning tools, or essentially those models that we started describing before, that are able to provide a level of calculations for what is currently existing, enabling the ability to start forecasting into the future what could be happening, and also identifying risk of failure for various assets. Through this, we also needed to make sure that that insight was surfaced in a reasonable way to actually enable the right people to start taking actions. So there was a layer of ragging, so putting a red, amber, green status on top of the visualization of the network. And within, I think this was within 2 years that it was achieved, a 3.4 megaliter per day savings in leakage and an annual savings of 1.3 million pounds. So there's a lot of functionality, flexibility, opportunity that exists with the right implementation of these really sophisticated and really exciting tools based in machine learning and AI.
Cool. Thank you, James. That's something that has been done. Now I'm going to talk for 90 seconds about something that we are in the process of developing, which is a use case around smart metering specifically that may or may not have occurred to some of you in the room, which is optimizing installation, optimizing rollout. So we're busy developing a value proposition around that optimization, leveraging work that we've done in telecommunications, in our telecommunications vertical, looking at mobile tower rollouts and fiber rollouts. And we're trying to take what we've done there and see how it can be applied in our space. So those of you who are perhaps approaching that point, looking at installing smart meters, wondering how you might do that process as an optimal fashion, please do come and have a word with us. We'd love to chat. We'd love to hear about your problems. Thank you very much.
Wonderful. Thank you so much. That was an excellent session. I think very much appreciated. Thank you for making it interactive, keeping us going in the afternoon.